Give it 30 seconds.
Okay.
I'll say now. Now.
Okay. Yeah, let me share the screen.
Would you mind if we open the screen?
Oh my goodness. Yes, of course. I'll tell you.
Oh, we can do it.
Oh, one second, something is off. Oh. Oh, what is coming?
We can just rotate it. Yeah.
So, Asif, should I start? Are you able to hear?
We are able to hear. Let's get it.
Okay. Let me briefly walk you through today the fine-tuning. So this is from Andy's Mountain. So I will briefly walk you through the fine-tuning. And this will be mostly just a fine-tuning, not the UI part. I'm using just off-the-shelf UI, and also the audio part will be doing it separately. So I will just basic fine-tuning. And I'm not touching the much detailed of this. So the detailed will be covered by Asif, I think, next month, right, Asif?
Yes, we'll do fine-tuning in detail.
So this is high level. So let me start with the data, like the raw data, what we have from the videos. We got it through Whisper, the final transcripts, raw text video. So let's start from there. And everybody had that the text file. So take the text file and we run through the chunker. The first step, if you see here, we run through the chunker and get it cleaned. So that is the first step, to just to clean it and paragraph it, the raw text file. So once we have this cleaned up file, then we need this in a very structured format. So for fine tuning, the basic one of the requirement is to have it in a JSON-L file format. So we need to structure the data in some kind of a like a question and answer. So we cannot take that as it is and fine tune it. So it's better to have it as a question and answer. And the approach what we are using is a context-based question and answer. So we have a context and a question and answer. So that is a context-based question and answer. And how are we doing this? Like, again, we have to do a prompt and submit that to the GPT-4 and get that question and answer in that format. So that's how it's been done. So once you have this JSON file, then you submit it and do the fine tuning. So that's the whole step at high level. And I can show you how the files looks like this one. This is the file. If you see here, this is from the raw text file, the chunk cleaned up file. So it's in the paragraph base. So this is how the each paragraph wise. So this is split. If you see here, so it's cleaned up. So take this file and you need to build it in a kind of format that can be used for fine tuning. So the next step is to do this. So this is how you get it. Once you build this, you have this context and a question and answer. So this is how the format you get it. And how do you get this format is like you had to run through the ChatGPT. So here is the system prompt. So once you run through this, you get a JSON-L file. So that can be used for fine tuning. So here is like a basic, this is a basic, and we have tried various methods and how to do that. And if you see here, as instruct prompt is like a AI instructor, expert in machine learning, analyze series of video transcripts, and what is the format you're looking, JSON format, and this is the context, and this is like example. So, and we tried out like various prompting. So prompting was little, initially it was like, it takes a few tries to get the required output format and how you want it. So this is how we did this. And once you run through this, you get that format.
Praveen, if I may interrupt you for me. And Srinath asked a question, which is that are the answers the chunks? No, the answers are not the chunks. What you did, what Praveen did, is you take the transcript, you create chunks. Now what you do is you give each chunk and you say to, and this is what this prompt does. You create a complicated prompt, careful prompt, in which you say, extract what is being said in this chunk. First, understand what's being said and write it properly. It becomes the context. Then, having written it properly, now ask a question and then provide an answer to the question. So generate from each chunk, generate context, question and answer. And like you ask it to generate as many question answers as possible. So what it will do is it will take the chunk. Now, if the chunk spans two different topics, so roughly speaking, one context is one theme, one topic, right? So it will break up the chunks further into topics or themes, make it the context. And of course, there is a difference between lecture communication, in which the language is as you speak. So it will make it more written language, readable, more readable, and then remove the repetitions and so forth. And then that becomes your context. But then it will produce a QA from that. So, and so if you notice what Praveen has done, which is, and Patrick and Praveen, Patrick, and all this, and his mountains, I apologize if I just say Praveen, but I know there's a whole team working carefully in the background on it. If you notice, it is not just a prompt. It's a pretty carefully crafted prompt. This prompt, first of all, if you notice, it gives a role. Right. Now, I noticed that some people were doing this. For example, Athira, you were doing it in your prompt. You started by first giving a role to that, which is a very good practice. Start by giving a role. You tell what it is. Then you tell what is it that the LLM is looking at. What is the input? You describe the input. You describe the output. Then you also give the structure of the output, but then you follow it up with a few examples. So you put in place for in-context learning. In-context learning is very, very important. Right? So you need to use every trick in the bag to get good results. These are some of the tricks we will specifically deal with as we move forward. And then, so I will let Praveen talk more about it. Yeah.
So why do you have the answer? You are expecting answer anyway.
No, it's a take this input. The answer is a triplet: context, question, answer. Answer is specific to the question that is being asked.
Right? You give you that format, question and answer.
Yeah, context, question, answer as a triplet. So you notice that line 16 and 17, if you look at your screen, it is context something, question something, answer something. So extract a lot of question answers.
Number of triplets depends on the number of topics discussed.
The actual topics discussed. Yeah, in the ideal situation, it should be like that. In that. That is it.
And the chunks, what he has done is he has just arbitrarily set it up, not the method you had mentioned to do the checking.
No, he has used that same thing, but even within that, sometimes you have multiple sub-themes inside it. Okay. So it does that.
Yeah.
Can we have one example of context question and answer just for understanding?
Oh, yeah, literally look at line number 14.
Now I have if
Okay.
this one.
Thank
See,
you.
look at this.
Oh, I don't know why you took Asif and his introduction. Let's take something more useful. Okay, let's look from line number 9, maybe. Or take some good example.
Here.
Okay. Yeah,
So
look
if
at
you
from,
yeah, it says context. Today we are writing a, let's say, time and machine learning. And if you see below the question, in what ways AI is changing the landscape of programming and code optimization? Answer: AI is changing the landscape and programming optimization during compilation and create efficient binaries. So this is the answer from this context.
Okay, cool. Now I get it. Thank you.
so Jay, Praveen, one more interruption, I apologize. See, guys, do you realize that this is far more involved than what you may have thought? We went from a raw video, right? You don't ever treat the text of the raw video as fine-tuning data, as some of you tried and came back and said, well, I don't know what to make out of it. That's not the purpose. From that, you use AI to create training data. This is training data. And you're using a LLM to create training data, which you will use to further fine-tune an LLM. Right? So it's a very involved and cyclic, it's a very iterative process. Go ahead.
So from, allow me to understand the whole process. From YouTube video, we created a text. Generated a text.
Large transcript. We chunked the transcript again using a large language model. You remember we use sentence embedding.
No, so from transcript, we created a sections.
Chunks.
And from chunks, we send these chunks to LLM model and ask LLM model to figure it out question and answer.
Context question and answer.
Context questions from those chunks.
Multiple context question answer triplets from each chunk. Right. So if you think about it, now see how AI was involved. If you think about it, we used a transformer just to do chunking. You remember, if you look at the solution, we used transformers to do chunking. So transformers came in there, right? Transformers came in even before that. The speech to text, the transcription was again a job of a complicated bunch of transformers. The Whisper architecture, right, did it. Then you again used a bunch of transformers, large language model technology, to generate just a training data out of it. And this training data will then go downstream and fine-tune a large language model, which you will now use to better do RAG.
So then question is why we are converting back and forth between the transformer output and context, and then again.
The reason for that is when you do chunking, you don't change the transcript. You just find the right boundaries to break it. See, chunking finds optimal boundaries that whenever you switch from one topic to next, it will slice it, right? But you still have a big chunk. And that chunk is transcript of a spoken language, the way we are speaking. Now, the nature of pedagogy, the nature of instructor relationship with a classroom is, you have to be repetitive, human beings. Like the same thing has to be said in 3 different ways. That's how comprehension takes place. But when you create a context, what was said, you don't want the repetition. You want a more condensed, proper version of it. So therefore, what do? You ask a LLM to take this thing and to reword it in a succinct way. It becomes your context. Then you say, okay, now create a few question answer on it.
So then from transcript to chunking, right? You may lose context between 2 chunks.
It is possible that you will, and which is why you should do chunking intelligently. You should do it at topic boundaries.
Yeah, that was my question, saying that,
Yeah.
is that required?
Yeah, see, there is a bit of loss at each stage, and you have to weight against the gains that will come.
So I
Yeah.
don't understand why you're doing all this to these chunks, right? Because you're adding content, you're adding questions to these chunks. You also have a search.
No, you're not adding it from the chunks. From the chunk as input, you're extracting these triplets, context, question, answer, triplets. And because, why are we getting these triplets? Because these triplets are the input to the fine-tuning architecture. Fine-tuning expects these triplets.
So my question here is, your semantic search and your elastic search comes back with a dozen chunks, for example. Those chunks, you process them into these triplets.
Yes.
And then
No. Search has not even come. I'm going from video. We haven't even reached RAG yet. What we are doing is you're taking a video, transcribing it, you get text. From the text, you are chunking it intelligently. Once you have chunked the text intelligently, you are now subsequently putting it through this technology to generate fine-tuning data. Now, with the fine-tuning data, you will fine-tune a language model. Once you have fine-tuned the language model, now comes the best part. That language model will be the one that will be at the tail end of the RAG. So the search results will be fed into a fine-tuned large language model. Right? At this moment, you're feeding your chunks, the search results, into a generic large language model, right? Whatever it is, OpenAI, whatever. But now you should be feeding it on something that has been fine-tuned on specifically machine learning lectures. And you'll get better answers. That's the point.
So one question asked, so even if Praveen doesn't want to answer, that's fine. If I want to now say that where in the video Asif actually answered this, where I want to go and look back at the video, you can only go back to the chunk, but not know in that particular chunk where it was answered, right?
That is right.
That information is lost, but we can go to section of within this section, he said it, right?
He said it, yeah. That's pretty much it. So this is the part that you lose something along the way, right?
Yes.
Because information is getting condensed.
Correct.
And so it's a lossy process.
But
the idea is
I
that
know in this 20 seconds, he has mentioned
somewhere,
with 100%,
That is
95% guarantee.
confidence. Yeah,
I'm not looking at
that is
something.
Yeah.
And by the way, I mean, you can, like, this is fine tuning. You're ingraining the data in the LLM.
Yes.
To answer it right away.
Yes.
But you can always use a combination of like a RAG and a fine tuned LLM together.
Yes.
To get you the metadata on where this was.
Correct. But what I was saying was, say, suppose this chunk came over 20 seconds, right? It will tell me in this 20 seconds he answered it, but I don't know roughly where it is. But guaranteed that in this 20 seconds he answered this question.
Yes.
Because you want to go back and listen.
Listen to that. So to that, one nice feature that Whisper's latest version has come out with is it tells you this transcript belongs to this point in the video.
Yes.
It gives you the timestamp.
Yes.
And so if you capture that as part of the metadata, like Satyam is saying,
Yes.
you can surface it in your search results.
You're correct. I mean, that is where I'm talking about the walk back, right?
Back,
Because YouTube video shows you that now.
Yes, it
In
gives
this
you the caption.
particular chapter, this much is the main topics of this chapter. You can go back and just click there.
Yeah, we had that.
Yes.
We had that in our demo.
Yes.
Oh, okay.
Actually, YouTube now with a premium user, they started a new AI service, which will do all this. You can interact with the YouTube videos and ask questions.
Yes. I mean, it's coming. See, guys, everything that you did, at the end of the day, you realize that there is so much compelling reason to do it that everybody should be doing it. But when you use those services, now you should feel the confidence that I know exactly how they made it happen. It's not magic.
Yeah.
You too can do it, right? So, all right, let's watch Praveen's thing.
I think there is a project where you give the project or in the YouTube, it can go and search exact where that you have spoken, that exact time frame. Yeah.
But I'm a premium user and they told me that this service is now available as a feature.
I didn't use it. Actually, could you point a link to it so that I can start using it? We can all start using it. I think most of us are YouTube premium users to avoid the ads. I became a premium user just to avoid the ads. Yeah. So, all right.
very expensive.
It is, yeah. Go ahead.
People who are on YouTube,
You can do one thing, you can have an Indian film. Between the against
Praveen, go ahead.
So yeah, this is basically, I think they are asking like how this is chunked and paragraphed. So if you look at this, there is no loss. This is just only put the boundaries. Actually, as Asif said, this is just splits out. If you see in a paragraph with the context based, little context based. So that's how it's happening. If you see clearly, it's doing this paragraph. See, this is one paragraph. So here there is no loss. It's just as it is, just splitting the paragraph.
I think, yeah, they were talking about context loss. This data is preserved.
Yeah.
I think in your chunking, it's I mean, when you talk about a couple of topics, the context can get lost, lost without overlap.
Yeah.
So.
There may be, that's happens. So that's what, if you have a very clean data, probably you can avoid even that further. Okay. So coming back to here, how this is, if you see here, the context based here, it may be, it's tried to do like a paragraph based into each topic. So we had that file split into 2K tokens actually to submit to the ChatGPT. So even that looks into the boundary and like a max 2K tokens, it will split. So once that is done, then we submit it to a ChatGPT to get as many questions as possible per file. So this is how we got. So we got roughly probably around 6 to 8 context question and answer per file. So if you see here, this is almost like a 11,000. I can show you here. Yeah,
we got a little under 12,000, isn't it?
Yeah, little under, under 12,000. So, and this is all JSON-L file. So each line, if you see here, it's an object here. If you see here, 26, 27, 28. So each is an object actually. Per line, this is per line object. So that's the pretty much about the fine tuning and this file, how we get it. Okay. The next is there are like once you have this.
Just to give you a sense of scope, guys, just to get, first of all, it took a long time to get the transcript and the etc. from that, but that was nothing. Just producing this fine tuning data, we ran it for what? It took us about 3 days of running.
Yeah.
Before we got this fine-tuning data out of the chunks. Right? Non-stop running we got. Yeah, go ahead, Shini.
What chunking logic was it?
It was just the same that's there in the solution, except that we expanded the window because we were sending it to this thing with the 2000. We expanded it to 2000.
So essentially, we read the spacey plus and transformer.
Yeah, I believe that's what we used.
Now, from each chunk, how many triplets were we able to?
Yeah, approximately 6 to 8.
Wow.
Triplets came out of it. So we had 27. Yeah, we should have that. We got about 27,500 chunks, isn't it, Praveen? 27,500 chunks of 2,000 tokens, give or take, right? So
the total size is size of the transcript is around 20 meg. It's a 4 million tokens, and the output what we got is around 17 meg, close to 3 million tokens.
But better worded, cleaned out data.
Yeah, right? Cleaned out thing.
A lot of questions here. I'll come to that. But one thing I must mention, guys, see, whenever you fine tune AI, and this is one of the things you will learn when you go into part 2, this is where it gets real. There is no point in fine tuning or training a model unless the data is good. Right? More and more, if there's one realization that's happening at the end of 2023, even in the community, the larger AI community, it's that data quality is everything. People are now finding, like, for example, the Phi-2, I don't know how many of you are following. Yeah, and so forth. A lot of these people are finding that you can take much smaller models, but if you put a tremendous effort creating good training data, right? These smaller models can do far beyond your expectation, right? So the new emphasis is let's before we go train a model, let us use all our horsepower, all our AI that we have to just create the best possible training data. And you can see some of that happening here, right? And you'll learn about this. Okay,
So,
Praveen,
so
please.
just to get my head
Mhm.
around it,
Yeah.
we had 300 lectures.
Yeah.
Let's assume that this was rounded out to 30,000.
Yeah.
Okay, so which means that per lecture, you gave 100 context. And if you had done 100 context, 120-minute lecture, say suppose 2 hours.
Yeah.
Means your stuff is a minute thing is captured in per context of what?
Roughly speaking, yeah.
So is
Because
that fair to assume?
see, one lecture, so I'll give you the exact numbers. One lecture typically that I give, which comes down to 3-hour lecture, which comes down to about 1.5 hours of actual
Right.
speaking, comes to about 35,000 tokens, 30,000 tokens, right? That comes to at 2,000 per chunk, give or take, it's about 1,500 chunks. 150, how much is it? No, 35, so 1,000, 35,000 means 35 divided, 17 chunks.
17 chunks.
17 chunks. A chunk becomes approximately about 6 to 8 like data points. So 17 times 6 to 8, right? So approximately 100 question answers come out.
100 questions, right? So
which is pretty rich.
Yeah, which is like a topic per minute is what you were talking.
Approximately a topic per minute. Yes.
Yeah. Okay.
That is it. Right. Oh, by the way, that's very good because in pedagogy, in teaching, education these days, they tell us that you must change topic every 3 minutes.
Yeah.
So I seem to be good. Yeah. Praveen, please continue.
Yeah, the I wanted to stress on that the prompting was which took us longer time actually, right? As if me and Patrick were like literally trying hard to get, because to get that kind of a question and answer, it doesn't simply, if you put together, you won't get that kind of a question and answer. Probably it will do just one question and answer per file, but trying to get 6 to 8 was like literally, it took us a couple of days to get the extract maximum out of that file. So that was like literally really challenging actually.
And that time you were interacting with OpenAI with blobs of chunks and trying to find.
Yeah, these folks tried everything. Right? Yeah, it is very. We had to write code that ran literally for days on the machine, and they not only tried OpenAI, they actually tried everything. They tried Llama, CPP. They tried Mistral. They tried a whole bunch of things to generate this data. So there's a lot of experimentations. Most at the end of it, one winning experiment is there, right? But for every winning experiment, there are 5 or 6 failed experiments.
So every round trip you have to pay for OpenAI, right?
Yeah, me too. Somebody was raising a hand, Satyam. Yeah.
So what was the fundamental breakthrough on getting some of these models to go from 1 triplet to 6 triplets or whatever? What was the key findings to create a better prompt? And maybe we'll cover that in the next course or whatever. We're just kind of curious because that meant there was a lot of experimentation on prompts, and eventually it started giving you multiple triplets.
Praveen, would you like to talk or should I talk? Why don't you go ahead and talk about this?
Yeah, see, the basic prompting, like what you see on the screen here, whatever I shared, it does that, but there are like other rules which like it gets into pretty much detail, like as if what we did is function calls and all this stuff, right? So once you get into that, it's get into more detailed of how it all the prompting thing.
Yeah. Satyam, hold your breath till January.
Too long. I'm going to make you very curious and hold your horses for 6 weeks.
Believe it or not, you have to apply such tricks that you won't believe it. You have to, at some point, come down to.
You're not even giving me a trailer of the movie. Forget the movie.
You're looking at it.
Open coloring was the one that helped a lot in structuring the output and making sure that our the data we're getting is formatted in the way we want it.
Yeah, the output format. Yeah, as Patrick mentioned, if you scroll down, Praveen, That's good. See, what you do is there is a way of doing things which recently has emerged as a very, very powerful technique by sending in literally Python data models and telling that your response must fit into that. Right? There's a whole technology,
Yeah.
structured technology will go into that. It is very effective. And see, many techniques you learn, and believe it or not, you'll learn that even bribing helps. Right? Did we bribe? Somewhere in the end, we bribed, right?
Yeah, that's in the, yeah.
Yeah. So, yes. So,
I will tip you off something for $500 or something was $500.
so, okay, guys, I'll just take.
I will keep you off if you are on the right track, $5.
Yeah, and letting them know it's critical to your workflow or your survival depends on it. So just creating the sense of urgency,
Yeah.
the emotional sense of urgency. Yeah.
Just wait for OpenAI to realize that you tricked it.
Yeah.
GPT, not a virtual GPT or
Yeah, so there is an interesting history to it. What has happened is and this is really being talked about on the internet. Chat GPT is beginning to show emergent human behavior. So human beings have a dip in productivity during the holiday season. And
Yeah,
what
that's what.
people are noticing, to their great surprise, and apparently it's just nobody expected it to do that. The Chat GPT suddenly developed senioritis, and it has started getting lazy and is giving short answers. And people are like, what do we do? So people have gotten to tricks that seem to work. So here are the 3 tricks that I know that work. One is you literally say, I'll tip you if you give me a good answer. So if you tip $10, you get a slightly better answer. But apparently, if you tip $100, you get even better answer. And it's proven, actually. A lot of people tried it out on that.
By 10,
Sorry? Yeah.
the bill increased by 10 or 100.
No, it doesn't. So the other thing that happens is people also found that if you tell it in the system prompt, today is May 1st, you confuse it that it's not the holiday season, then it tends to produce longer and better answers. It is not lazy anymore. That is something else people notice. Another thing people noticed in this whole space is they found that if you put emotion into it, my job depends on it, my life depends on it, right? Or something very pretty dire. People are talking about that it makes a difference. And so, it's a very fun thing. These LLMs are weird things. None of us understand how their brains work. I mean, metaphorically, if you think of them as having brains, we are only learning about their emergent behaviors.
So the job profile of a new prompt engineer should say English major who's a con artist.
Yes.
So that is,
Because I've been only looking for English orders.
Yeah.
So I forgot
so that
the
is
spawning
exactly
part.
what the Microsoft VP said.
Yeah.
The next language when people say going to be popular, and it was English.
Yeah.
And people are like, what is she talking about? And
That is
what
right.
It was.
Yeah, as Sachin pointed out, the big thing of 2023 is when English became the leading programming language.
Yes.
Yeah. And I'll just take a small digression because, and just to amplify the great work Praveen has done, guys, this is for real. More and more, we are discovering that many of the tasks that you could do with traditional programming, now you can do with prompting and large language models. Sometimes things that you wouldn't expect, like for example, Patrick, can I give you an example, the Gatatron example, or that other example, the medical example about the survival models?
Sure. Yes, Asif. NYU-tron.
Would you like to talk about it? Because since you brought it up, it's a very powerful example.
Sure, Asif. So there, as early as December of 2022, last year, the University of Florida released a model where they used all the de-identified healthcare records of their patients and their healthcare services to build an in-house language model, and then they released it. So they had it the better part of 2022, and then they released the weights and hugging face, I think early this year. So what happened was because the weights were released, uh, this also prompted other research institutions. The New York University, they tried the same experiment in their own with their own data. They identified also in their healthcare data, and just to compare. And they reported they wanted to. The idea was how far can these large language models perform tasks that were originally reserved for traditional ML models. So ideas like 30-day survival analysis. So is a patient going to get readmitted, or is a patient going to die within 30 days? And these models, the idea behind this whole project of NYU was, can we use clinical data, which is maybe 90% in written in English or in text. Even if it's an X-ray, it will have an X-ray interpretation in English. So the assumption there was, since we're looking at most of this patient data interpretations, and all of them are translated by domain experts from English, can large language models perform as good a performance as these traditional ML models that picked up every other data point? And surprisingly, it performed way better for survival analysis, for categorization of all these patients, like passing of criterion, for triage, for a lot of tasks, and for claims denial. They were able to figure out that it's actually approving better claims than the original systems that they had in place. So a lot of this information was good. NYU said, okay, we're now using it in our local system, but somewhere hidden in that paper, they mentioned that this University of Florida's model called Gatortron, which was the one that was released earlier this year, the weights, performed just as well. So if you want to perform the same kind of analysis on patients in the healthcare space, you could just use the one that's available in Hugging Face now and apply it in the healthcare setting.
No, thank you, Praveen, for that. So, Patrick, for that. I would like to add a bit of color, guys. Survival analysis. So, two of the things that you talked about, these are really hard problems. Survival analysis is the foundation of reliability engineering. Today, when you take a flight from here to India, you realize that you're flying in a machine that has hundreds of thousands of parts. Any one of those parts will fail someday. Every one of those parts will fail someday, right? In your flight, theoretically, any one of those parts can fail, compromising the integrity of your flight, right? You're flying over cold, deep ocean, and yet your only concern is that, the other guy is snoring next to me, or something like that, some silly thing, isn't it? Why is it that airplanes don't fall off the sky? A lot of it has to do with the reliability engineering and preventative maintenance. That comes because we know very well exactly when this component now is likely to fail, and you replace it way before that. You do preventative maintenance and you do inspection and so on and so forth. Human beings, when you have an illness, the first thing you do, especially if it is cancer, God forbid, the first question that you have as a patient, and perhaps the only question is, doctor, how long do I have to live? Right? That is survival analysis. Survival analysis was started, the great luminary of this was the great statistician, today you would call data scientist, Cox. And Cox proportional hazard model was one of the crown jewels in survival analysis and these models. These were the crown jewels of statistics, really. I fancy myself as one of the persons who has really spent time mastering survival analysis. I've used it extensively in many domains, including studying people's happiness in workplace and things like that. Right? And I would fairly say that I'm one of the experts, right, who has spent a lot of time on it. And I did not, in my wildest dream, think that a large language model could do better survival analysis than this very, very mature field that has hundreds of machine learning models that people have evolved over the last decades, that a large language model would go and beat it. And yet it seems to be. Other thing, coding. Like when you send a bill to insurance and insurance decides to approve or not, or a hospital decides to approve a procedure that a doctor is requesting or not. It requires a lot of judgment. They're coders, they're people, experts, evaluators, and sitting there. They have to use a lot of judgment and experience to do that. To think, as Patrick mentioned, that now an LLM is able to do that. These are non-trivial progresses. What is happening is LLMs are proving to be generally better than the domain experts. Really better than the domain experts. There is a project that I'm working on. I can't talk about it. Suffices to say, it's in the food industry because of the NDA. I'm realizing that certain decisions that I had to make predictions, which required in-depth understanding of cuisines and what a good chef would do, LLM is coming through with it, right? And so it goes to the statement that, see, Andrej Karpathy wrote an article, I believe in 2017, way ahead of its time, or 2018, in which titled Software 2.0, right? In which he said that the old way of programming, imperative, you code it, was one thing. But machine learning is bringing a completely new paradigm of programming. You show it a few examples, it learns from the examples, and then it does things. That is today very much a reality. In fact, we have gone, it is remarkably beyond all of that now. These LLMs are, you just make a picture of an interface, user interface, it writes the React code for you.
Actually, one of the key points he made is there are problems like autonomous driving
that
cannot be solved with
which of course is
at all.
At all,
The
exactly.
only way to do it is
through this, yes. Yeah, Satyam is mentioning the point, which is at the heart of AI actually, that we mentioned that AI solves problems that can never be programmed at all. Self-driving cars, helicopters. How do you fly autonomous helicopters into a war zone? Or you just give it an objective. You have to reach this point, avoid all obstacles. You can never program it. AI does it, right? And this is a point that has been made over and over again by, actually, I believe Professor Michel made it in the late 90s, actually, this point that there are certain things completely non-programmable that AI can solve, and so forth. So anyway, guys, just as a giving you a context of where LLMs are going.
On Patrick's finding that Florida and NYC, where they said that the survival thing, though it was de-identified or
anonymized data.
Anonymized data which was there, don't you have to have the same demographics as the patient? Because if that was an older population, what the survivals were, comparing to the ones that you are having in NYC, unless those survival across different demos are also going to be different. So,
no, what it does is,
early. I mean, we're just
it is. And so we have to see what the controls were. But suffices to say that if it is even achieving equivalent parity in even some areas, people will now work on it and expand it and broaden it beyond that. The point is that it's so unexpected that it would happen. Right. It is so much about structured data, and suddenly an LLM is doing better at a structured data task, right? It is already doing better at writing code than most programmers, right? Even Karpathy mentioned in one of the talks that today, even when he writes code, and one would imagine that these guys are writing non-trivial code, he says more than 70% of the code that he is written by the Copilot.
No, 90%.
90% is written by the Copilot, right? And I see it in my case. The Copilot has learned. If you guys have been reading my code, you notice that I have a pretty idiomatic way of writing code. It's a pretty structured way that is sort of different. You can look at the code and tell Asif wrote it. This Copilot has trained itself on my code. And now, when it makes suggestions, in the beginning, it would make suggestions that would annoy me. And now it makes suggestions that looks as though there is another Asif clone, right, suggesting it. Right? These things are miraculous. I mean, 10 years ago, if they would have come out, people would have declared that AGI is there. AGI has been achieved, right? Obviously, we keep moving the goalpost of AGI, but the question to ask is, at what point will we say that we have achieved AGI? These things are getting dangerously close to it. Anyway, Praveen.
Good thing is when I open your project and start coding, I code like you.
Oh. No, because the co-pilot has gone and read my code, isn't it?
Yeah.
Yeah.
That's a good one.
You have done.
Right. So,
Praveen, can we go
Yeah.
to the demo straightly?
Yeah. So even this prompt, we got it generated from ChatGPT. So that's what I wanted to tell you. So I had put up a quick write-up in the morning today, and it's just I'll briefly walk you through what it's like for fine-tuning, fine-tuning, and challenges in data preparation. So we went through that, like how the challenges, and there are various formats available, QA formats you can check online on Hugging Face, Vicuna, and other stuff. In data formatting, it's like how you do that. There are like various format, like instruction input output format, context input output. So there are like various formats where you can follow that, and privacy. Like when you give all this data to, this is educational material, we can give it. But if you have your own private data, you cannot give it to ChatGPT to form a question and answer kind of stuff. So that's, you need to be careful. And the fine tuning process, like you can use all kinds of fine tunes, like use the transformers, accelerator, LoRa, QLoRa, all these kinds of stuff. So just walk through that. And if you see, I have a couple of, this is all the various data sets where like very popular, how they use it actually, input, output, instruction based. And some of them use instruction, context, response, and category. They have a category too. I thought of looking into this, but it's like you can categorize each topic, whatever the Asif has given, so that you have a category in that. And there are something like question response system prompt, where you say the system prompt question response. So these are the like very popular data formats. This is Open Orca is a very popular data format. This is one of the format recommended. And I think there is one more. Yeah, this human value. This is a continuous question and answer kind of stuff. So where you can have a multiple question answer, so that it goes in a conversation. So this is one of the stuff I like, but all these things you have to keep try out, and you need a lot of time to do this actually. So that's the thing.
Something that Praveen mentioned, I don't know if you caught on to it. He mentioned that he used an LLM to even write the prompt that would go into an LLM. Right. That's something quite remarkable and recent discovery, that LLMs are much better at writing the prompts than we are. So you can actually give it and say, write a good prompt for this task, and it will do that.
Yeah, you say what is the input and what is the output you are looking, and it can write the prompt for that.
Yeah,
But
Asif, a quick note on that context. I think the research suggested the reason for that LLMs being good at prompting is because the data it's trained is actually written by professionals, and so much of the people that actually write papers, books, blah blah blah, all that. So when we write, we tend to write in our own fashion, but when it writes, it kind of writes the way it is trained. So there is a bias into why LLM writes the better prompts than what we do. And this is where Elon Musk's Grok is basically shifting the whole dimension, bringing in the psychology and multiple ways of human way of writing it. So just giving you that perspective, because there was a research paper on this, like why LLMs write prompts better.
Yeah, actually, could you please share that research paper? We would all love to read it, I'm sure.
Sure, Asif. I'll get it.
True, and if you forget, GPT GPT-2 had all the bad words and things like that before they cleaned it up.
Yeah.
They locked it out because it came from Reddit.
Oh, yeah.
And so the GPT would get really annoyed if you didn't agree to what it was saying, and it would go into completely nonsense mode. So that they clipped all of it. So now they kind of made it a little bit more, what do you call it, user-friendly.
User-friendly.
So answer the question here is, so if you are prompting a specific LLM, do you create a prompt for that particular LLM?
Yes. Unfortunately, at this moment, the prompt engineering is somewhat LLM specific. Certain LLMs, for example, try bribing Bard. It doesn't work. Okay? But it works with ChatGPT, it seems.
For now.
For now, it doesn't work. But senioritis will kick in there too. Yeah.
Yeah, as if I can straight jump into the demo.
Yes.
Yeah, this is like hacked up everything in the morning, Asif. So
That's okay.
yeah, I was trying various formats and UIs, but at least this finally found to be working. So see something. So Asif,
Language of goodness.
so
But
Asif,
it's even captured the style. That's awesome.
Yes. So I don't know, guys, do you when you read this answer, does it read like me or what I would have said?
It should sound like me.
Well, they didn't put the sound part. He hasn't put the sound part yet.
Yeah, I want to hear the sound. I don't know if you say, "Oh my goodness."
Yeah.
You would probably say something a little different than that.
I think he says sometimes, "Oh my goodness."
Yeah, I've seen good.
Yeah,
Oh my goodness.
he says, "Oh my goodness" a lot. Yeah.
yeah, Asif, what do you want me to?
I think you wouldn't say I'm just an AI though. That's not good.
No, I think that's part of the system prompt or something.
Yeah, that's a system prompt. Yeah.
How about guys ask a question?
Yeah.
No, I think they'll do sound separate. So what is the thing, Praveen? When will you show the sound part or the UI?
The Patrick will demo the sound part.
Patrick will demo that part in a moment. Yeah. So guys, ask a question. Maybe I'll ask a question.
Let's ask
what are the advantages of ensemble methods?
So this one's working purely on the fine-tuned LLM
Ensemble
RAG.
methods. Yeah, ensemble, ENSEMBLE. So this particular example, at this particular moment, you're not backing it up with RAG yet.
No.
It's okay. I think it will recognize the
ensemble is SE. There's no SEM. It's written as ensemble, but pronounced as ensemble.
No, it will understand, I think, Asif, with the typo.
Yeah. Yeah, let's try that. By the way, you realize that now this is coming from a local model. It's not coming from OpenAI. This is coming from a locally fine-tuned model, Llama.
Can it deal with typos?
It's reasonably good, robust against typos, but yeah, it would be nice if you fix the spelling. I think Praveen just stepped out.
Sorry, guys, my daughter was pulling, so.
Praveen, there's no ensemble doesn't have, okay, that's all right.
It understood ensemble.
So background, the lecturer discusses the concept.
How big is the model?
Yeah. So say that again.
How big is the model?
This is a very small model. That is why you notice that the first few sentences are relevant, and after that, it goes a little bit.
It's a Llama 7B.
Yeah, Llama 7B. It goes a little off track. And one of the things we are hoping, and in fact, Praveen is helping me, is that if we can load the mixture of experts Mixtral on this, yeah, and fine tune that, we may get much better results. Yeah. I hope that you guys are bringing it here as a sponsorship from your company.
No, Asif, this is going for the next topic because of the stop sequence. So
Oh,
we need the prompting. I need to put the stop sequence, and I'm just today morning I'm looking into it. So once we put that stop sequence, then it know where to stop. Otherwise, this is a generative model, right? It will be keep generating it.
That is right. So we need to do that. Okay, Praveen, Prakash, you had a...
Yeah, you said they did a fine tuning on the Llama 2 model. So you explained the technique of making the Llama 2 model smaller and smaller, and then do fine tuning on top of it.
So they started with a 7 billion parameter Llama 2, and they just fine tuned it. They didn't do LoRa, they just do direct fine tuning.
Yeah, they did not do LoRa.
It's a direct fine tuning. So those techniques, LoRa, etc., right, we will address when we get into the second part. Yeah, you'll do a lot of that.
Actually, it almost feels like, I mean, if you look at all these experiments across the board, whether you look at like chunking, you look at fine tuning, you look at all this feedback loop and all that kind of stuff, I literally feel like, all of us will do one thing, and then you will probably come up with like, this works the best, this works the best, because I don't even know how one person can do all of it.
Oh yeah, you cannot, yes. And that's why, see, I wanted the boot camp. People got busy because they have professional lives. But like the whole point was to learn from each other, and what each of us bring to the table. So.
And even this fine tuning is it's a pretty vast actually. It's not just engineering; it's an art too. Because I was reading like if you have like a 50,000 or a 100K rows, you use a smaller model. If you have a million, then you go for a 13 billion or like a bigger model. So there are like various, like depending on your data size, what model you choose, and all those stuff.
Sorry, that sounds counterintuitive, right? If you have a lot more data, you start with a smaller model, right? Basically, I mean, whoever built Mistral, or like, when you're building from scratch, if I have a lot of data, I should be pretty much starting from a null set.
No, that's what he's saying. That if you have I mean, when he says that if you have just a few 100,000 data points, you start with 7 billion or something. But if you go to millions of data points, you must take a larger model.
And that's what I'm saying, right? Isn't that counterintuitive?
No, the thing is that the more data you have, the less likelihood it is that it will overfit. See, big models have a problem. Big models with small data, they just memorize it. That's the main problem of overfitting. Yeah. You give a big model not enough data, it has in its parametric space, it has the ability to literally memorize it. In fact, one of the paper readings that I'm going to do is why do large language models and how do they memorize data? And so, for example, recently there was a paper that came out. You can scalably extract a lot of the training data out of LLM, which is a huge security problem. So that was a security paper I was talking about that I'm going to do.
No, I mean, I have a completely different discussion that I'll bring up at the end of it.
Okay. Yes. Yeah. All right, Praveen, you continue, please.
Yeah, even the data is like less than 100K. They don't even say you have to be more than 100K data to do a fine tuning. Rows, 100K rows, probably.
Yeah.
So you want to run through that as if you are stuff.
Praveen, I mean, I've heard those statements, but like I don't quite agree because I have seen, and Andrew makes this point here. He has some examples to show where you can actually make a substantive difference fine-tuning a model with as little as 20 or 100 rows.
Yeah.
So it depends on the problem you're solving, and the mileage varies with that. So
no, there are like notebooks, examples. They have done it like just with 100 rows.
Yes.
So Asif, you want to just put in your questions?
Yeah, what are the key? Yeah, why don't you do that? You have all of those. Yeah, what are the key components of attention in a network? Yeah, let's see.
This human board and board tags.
The lecture discusses the concept of argmac. I explained that these are yeah, after that, it gets it needs to be, the fine tuning needs to be done. Again, this is the end result of a lot of fine tuning experiments, but still some issues have to be weeded out. So just read the first few sentences, guys, before the background. The key components of attention in a neural network includes KQB. These are to compute the attention scores by taking the dot product of which is to applying to obtain probabilities and then using these probabilities to weigh the importance of different parts of the input when making a prediction or decision. Sort of true, but though this is, see, most people mix up self-attention with attention, and this one is also doing that. The one statement that it missed was that attention is alignment of something to the context. Right, but it's still okay. And this is almost all the teams missed that one. So this is that. Want to try the next question?
Yeah. So Asif, that the one we tried, universal approximator. What is that? Do we want to try?
Oh yeah. Why are neural networks considered universal approximators?
There's something with the stop token, I think, Praveen. It's prompting again. Right, the stop token. It needs to be configured.
Yeah, that's I had to do that. Yeah.
Yeah, Praveen, if you could run through all the questions that different teams we gave as a benchmark.
Okay.
I forget list of questions. Then we'll go to Patrick's demo. Yes, this is very well done. This allows for interpreting the results of likelihood of probabilities of learning to each strategy, essential for classification tasks. Okay. The first few sentences are on the dot. After that, it goes. Next question was.
So when you say that it goes haywire, is it picking up things from your lecture and trying to come up with it, or what is it? Why is it going haywire?
That's a good question. Actually, I have to go deeper into it, but I think see, these things, it's called the diffusion of errors. It's using a softmax temperature. It will produce so many words, but after a certain number of words, based on how powerful it is, errors are adding up. And after a little while, the next token that sooner or later, it will produce a token. It shouldn't have token. But now it has to take that into consideration to produce the next token. So that fatal deviation leads to more and more, and it completely goes off track.
So like an ARAG detection and stop.
Yes. Yeah.
Or a stop token.
Stop token, yeah. That's right. What are the key advantages of using RAG rather than directly asking the LLM? Key advantage of RAG instead of directly asking is that it allows for more structured and focused interaction with the model. RAG enables the use. First, retrieve relevant information. This is excellent. Informative responses. So what happens? Okay. Don't read anything that starts with the word background.
Yeah, the next, I had to put through that system prompt stop sequence as if. So that's the.
Yeah. Nice.
Is this way of understanding fairly correct? That say suppose on the web we have so much of data, right? And you ask any particular question, let's assume that probably say some 10,000 data points show up. And even if you pick up the first top 8 or 10, they are related to the top. Versus here, when he starts to pick up stuff, even if he gets say 20 or so, the first 2 or 3 or 4 may be related to your lecture, but the rest of it is kind of not related to the topic. It's something else that.
No, Sachin, it's not like that. It is the diffusion of errors. Let me give you an idea.
Okay.
Suppose, see, so imagine the softmax function with the temperature associated. So you're sampling off the softmax.
Correct.
What it means is that the most probable token that you should produce is coming out.
Right.
Now the question is, at some token that you emit, what will happen is even the tokens that produce out, the confidence is not that high.
Correct.
And especially because you're sampling, you may pick up a low confidence token, low probability token, because you're sampling. You're not picking the highest probability answer.
You shouldn't be sampling.
No, it is. You need to, because without sampling, the answers are just dead flat.
But the thing is, we have fine-tuned it.
No, even with fine-tuning. Your sampling is built in. Sampling is baked in. You can decrease it. By the way, how much did you put the temperature to, Praveen?
Default 0.7.
No. Make it 0 itself. And let's try this experiment again. Okay. So anyway, what happens is because you sample, sooner or later, you'll produce a low confidence token.
Correct.
That is the beginning of the error diffusion, right? Because that leads to the next error and the next error. Because you're committed to that path. Now you need to make something logically in continuation of this, and soon you're off the track.
So if you change the temperature, I think it should look very.
It looks better, but at the end of it, even at 0 temperature, right, it's still sampling.
Sampling, right.
But one thing that I can see from the response is that it's not just your whatever you spoke, you have when I'm part of the transcript, whatever all of us spoke is there.
That is true.
So probably in Whisper, we need to kind of just segregate out whatever.
That's called diarization. So diarization is something we'll learn to do in part 2.
She was doing it,
okay, very good.
It was giving the speaker.
Yeah.
So one thing that we are trying to figure out is which speaker is who. That's something that you were trying to.
That's right. So so she's doing diarization, and what you have to do is in fine tuning, you have to clean the data by removing everything except from the primary speaker. Like somewhere in there, there's iPhone 2 or something coming in, right? Like that. So all of those things you have to remove. The other thing is if you find a sentence in there, as you're doing the sentence comparison to add to a chunk, if you find that it's way off, you just ignore that sentence, right? So because, there's some other thing came in, interruption came in, you need to learn to ignore that. So see, data cleaning, right? Companies live or die by data cleaning. At the end of the day, the quality of the product is not so much about how bright your data scientists are, but how diligent they are. The people who clean and prepare the data, companies live and die by that. In my opinion, just an opinion, right? So brilliance matters, but also hard work. I think reminds me of Thomas Alva Edison's famous saying that genius is 1% inspiration, 99% perspiration. And that's certainly true in AI projects like this. There is genius required. You need brilliant minds to discover something new, but that is 1%. The rest, 99%, is grunt work. And it is the grunt work that people don't want to do. You are seeing the effect of how important it is to clean. Praveen and his team, Patrick, etc., they have put so much effort to create this cleaned out data. And still there is scope for work. Right? And that's what you will learn next time.
The context matters. I mean, the score. Right?
Yeah.
So if the score was, you took only chunks that were high score, then you got exact answer. So now you're getting a whole, you have so much content. It's getting a little confusing.
No, we need to investigate this a little bit more, and specifically why this is happening. There's more to it. Like Praveen said, this is not so much a deep reason. It is something as basic as the stop token wasn't there. It's a bug at this moment. Your broad point is true, though, but in this particular case, it is something very simple.
So I found even when you get the chunk, right, you have some 20, 30 chunks. The ones at the bottom are useless. So you just take a few on the top, and that's all you need.
Which also is part of data cleaning. Exactly, yeah. Right, and also in the beginning, the introduction, it's a good morning and California, all the things that I say to set the context. Maybe that can be dropped, cleaned out and so forth. Praveen, are you done with all the questions? There's one more.
Yeah,
Right?
see, Asif, did you go through this question? Commonly
What is
loss function
the
is
commonly used loss function in sentence transformers? Why is it necessary? The commonly used loss function is typically a cross entropy loss function with negative log likelihood. This loss function is necessary because it quantifies how well the generated text matches, which is essential. No, it missed it completely because it's cross entropy. It is not cross entropy. It is, what is it? For sentence encoders, what is the loss function you need?
triplet.
Triplet, contrastive loss. The whole point, the whole difference between a sentence encoder and a standard BERT is BERT will use a cross entropy loss for these situations. And here you use contrastive loss. Nice.
So are you ever going to talk about this chain of reasoning and chain of thought?
Absolutely. That's a core topic. We're going to do it deeply. Prompting, right? As I said, right, prompting is a big subject. It may so happen that if we don't cover all the topics in LLM part 2, we might have to do LLM part 3 to come to graph networks, because it may so be that prompting and fine-tuning may eat up all the time.
So what I've been reading, it's still like 10, 15 years away. Is that true? I mean, the chain of reasoning, chain of thought and all that.
No, they are very real. We can do it right now.
Then this we could have.
Asif. So my idea, Sachin, for chain of thought is, you know how humans have a system 1 kind of thinking and a system 2 kind of thinking, where system 1 is immediate, right at the point in time recall, or whatever you had known at the time. That's what you churn out as information. So the LLM has this kind of system 1 replies to everything first. And it was only with craftier prompts, and chain of thought really was one of the first that actually dug deep and sort of transitioned the LLMs to access that system 2 kind of thinking, which is a little bit slower, a little bit more decision-based process, and most of the time much more accurate. So I think there's a case to be said. If the LLMs even react to emotional stimuli, then maybe these chain of thoughts are your way of like when you're conversing with someone, it becomes a lot deeper because it causes them to think and take some time to actually process the information. So there is a lot of value. If I were to pick one prompting technique to create, let's say if you're not getting the exact response you wanted, I would choose chain of thought, just to let them think step by step, or break down a problem without even seeing other problems. Just asking them to break down the problem themselves. Then I think the LLM already performs well for that. But it doesn't perform the best when the parameter size of your model is small, because so just like someone who isn't as knowledgeable or not as well deeply in the understanding in that field, it will take a lot of extraction of information or question and answer before a not so learned person gives you a really quality answer. So a bigger parameter model that has all these deeper connections will benefit better from all these prompting techniques compared to the smaller ones.
So where I was getting
yeah, Patrick, may I add more color to what you said?
Sure, of course.
So first of all, guys, see, Patrick is absolutely the expert in prompt engineering. Like, he's way better than me. Like, I'm like kindergarten compared to him, because he does it day in and day out, and he is really very good at it. So the point that he has just made, I think, is a pretty profound point, and I would like to add more color to it. See, guys, there's this famous book, Thinking Fast, Thinking Slow, right? The author of that, why am I forgetting his name? Say that again, Patrick?
I think it was Kahneman.
Yeah, Kahneman. So Kahneman got the Nobel Prize, by the way, for that, and this line of thinking and this line of work. What it says is that even the brightest mind, if given a simple problem, we tend to do what is called thinking fast or system one thinking, what Patrick calls system one thinking. And then the reason is that that works most of the time. But there are many situations where that is counterproductive. You need to think slowly, carefully to come to an answer, and you'll come to a different answer. So one example that he gives in his book about this is, like, if I were to ask you, there is a quiet person who likes to be quiet, is studious, and so forth. Yeah, living in, let's say, Nebraska, whatever it is, somewhere. I forgot the exact context. And is that person more likely to be a farmer or a librarian? What would you say? Person who likes to be quiet, reads a lot of books, likes to read books, etc. What is she more likely to be, a farmer or a librarian? How many of you for farmer? Just two. How many of you for librarian? Lot more, right? But actually, that is not true. If you think a little bit about it, the statistical distribution of people is the librarians are rare entities, farmers are common. And even if you look at the small proportion of farmers who love reading, right, they overwhelm the population of librarians. So obviously, she is more likely to be a farmer who happens to like books rather than a librarian, right? So that is system two thinking. That's what Patrick calls system two thinking. Now, what he's pointing out is a profound point. Very much like human beings, the LLMs are susceptible to defaulting to system one or thinking fast, coming up with a plausible sounding answer rather than reasoning it carefully. And therefore, the point he's making is you need to, one of the techniques that you must have almost as a de rigueur, almost as a necessary thing in your prompt is force it into the system two thinking by forcing it into a chain of thought or one of its variant, chain of thought, tree of thought, and so on and so forth. Force it into system two thinking so that it thinks carefully about your problem. Right?
So where I'm very worried about this is them putting the LLM behind Khan Academy. This is what Madhu had also suggested. Because what's going to happen is there is going to be this large set of videos and things like that, what people have created.
Yeah.
Now, when the kids are asking questions, this damn thing is going to come up and write in very convincing English.
Yeah.
Something that the kids cannot basically break down and figure out. And my take is that part of it trying to glue together something in English is where the confusion is going to happen. The kids will not be able to figure out if there are two videos, they're bringing on from two videos, two concepts. They'll get very confused when it tries to go across it and puts its own interpretation of the thing. Who's going and checking for every damn question and what the answer is going to be.
No, Sachin, that is absolutely true. In other words, most of the time, simple thinking works. LLMs give correct answer. But when they are wrong, you can't tell. So it is replacing the precise answer with a plausible answer.
Yes.
And soon it will perpetuate onto humanity a mass of students who have been educated on plausible answers rather than the precise answers. And so you will actually have a loss of knowledge, right, in this whole, and that is a real problem. Actually, people are seeing that. Somebody told me that the chat GPT generated content or open LLM generated content is so much now that it is diluting, it's making it hard to find the right answers.
Yes.
Because it's just flooding the internet, right? So go ahead, Patrick, please continue, and Praveen.
Yeah, so the Asif, the last question here, image grounded, and the next, tell the story Asif told.
Yeah. I don't recall telling any such story. Okay, thank goodness. In another variation, somebody made me a warrior or something like that.
Yeah, I found it.
Yeah. This is embarrassing.
Voice reflects, but you told us many stories.
Yeah.
So this is the limitation, the censored model, right? The Llama 2.
Right. That's
so
nice.
That's why I think it's coming in here.
This is actually on this question you win hands down, because it says I don't remember telling any such story.
But you had told in the support vectors, the SVM and all the
River and
river and
analogies.
all, why
Those are not
doesn't
stories,
that
those are
work?
analogies. Now, by the way, ask this question. How can you use a river to explain a support vector machine?
Or maybe how did the instructor work?
So guys, do you realize that this is not a question you can ask ChatGPT because it doesn't know? That's an example only I use, the example of river. And so that comes from fine-tuning. And the answer here is the lecture uses the analogy of a river to explain the concept of support vector machines. SVMs aim to find a river or a boundary between classes that simplifies the data, just as a complex river in reality is simplified by connecting individual droplets of water to form a straight line. SVMs seek to simplify the classification problem by identifying a decision boundary that captures the essence of the data more efficiently. This analogy helps illustrate blah, and it's getting close. It's pretty good. Yeah.
Excellent.
And that is something you only get with fine-tuning. And it gets better. Now, the next step would be to back it up with RAG, because then it would bring up the actual context and give it the chunks and give it to them. Nice.
So, why wouldn't this come out with RAG? Because
both.
Like, my point is, let's say when you say, explain to me using the context of whenever on the support vector. If I had a RAG, it pulls out the data that is talking. So let's say it pulls out a couple of these paragraphs where it finds that the material covers me.
Right.
And then I give that to the fine-tuned model, which is more stylistic stuff.
Yeah.
Which talks in your style. Why? So are you saying fine-tuning will produce better results, or
no.
RAGs will produce better results?
So Satyam's question is, why isn't RAG enough to do this? Why do we bring fine-tuning? Am I saying that RAG will produce, fine-tuning will produce better results than RAG? So the answer to that is no. Actually, they are orthogonal. They have different strengths and weaknesses. See, when you RAG it, what happens is you search, you get chunks. What you get is local information, the most relevant local information. But what you're missing is the global context. When you fine-tune a RAG on all the text, it can juxtapose these search results against a much larger backdrop of information specific to this topic. And so you should always juxtapose the local, precise, specific points against the larger learning or the more global learning to get the best results. So it is not search results versus search plus a generic LLM on one hand, plus just fine-tuned LLM. It is both search, RAG it, but in the RAG put a fine-tuned LLM.
So couple of follow-ups, right? As a train of thought. See, maybe not a general LLM, but a general ML LLM. So we fine-tune the LLM with all possible ML lectures, whether it was from us or it was from Andrew NG or whoever is teaching, right?
Yeah.
So you got a lot of ML knowledge into it.
Right.
And then now the thing is, I take your specific stuff in a RAG-y manner, and then I take this particular context, because it will find that, river and support vectors, and it will find me paragraphs for that.
Yeah.
And now I give it to a general ML LLM. Wouldn't the result be as good?
Yeah. So Satyam is asking this question that if I fine-tune it with all machine learning, a general machine learning LLM, wouldn't it give equivalent or better results with search and that? So see, Satyam, here's the answer to that. Fine-tuning is not a one-shot game. What you should do ideally is, it is a funnel. You take a LLM, which is very general.
Yeah.
From that, you derive an LLM, which is machine learning specific through fine-tuning. From there, you derive another LLM, which is, let's say, based just on my lectures right? Because there may be things that only I speak about or analogies that I give. Now what happens is, suppose I ask a question that, how can we think of creating, like, how can we give me a way to think of support vectors, intuitive way to think of support vectors. When I give that, what will happen is that the search results will not produce the right chunk. But a LLM which has been further fine-tuned on my lectures will immediately catch on. See, you have two sources of information: search results, which is the retrieval augmentation. The other is the parametric memory of the LLM itself. In the parametric memory of the LLM, now is the idea of lighthouses and the river. And it will say, oh, intuitive explanation, I know it. So the thing is, you have to realize that there are two possible sources of good answers, which are complementary, and you want to use both, right? That is the point of RAG.
So even the question is what is support vector? If they is asked to a question of what is fine-tuned on your content,
yeah,
versus what is fine-tuned on the machine learning data content, there is a difference.
Yeah. Right. So for example, just ask this question, Praveen, how do you relate the concept of, the concept of support vectors to lighthouses? And you guys can go try it on, for example, ChatGPT or something.
You can try on our model.
But who knows, ChatGPT has already scraped my lectures.
So I'll tell you why. Because my RAG wasn't working perfectly, my fine-tuning is not working perfectly, and I'm having a hard time figuring out what's right.
So this is it. No, you have covered only half the distance, Satyam, I'm telling you. As you make progress with these things, right, you will see how all of these things improve.
So, as a question, how do you relate the lighthouse?
Relate support vectors to lighthouses. Light to the lighthouses. Yeah, see, look at this. This is not an answer that you would get, for example, from even a AI trained, a machine learning trained LLM.
Because this is your content.
My content, yeah. And it is able to give that.
So for just RAG-based system, we got a very small and concise answer. It says the support vector in the context of support vector machine can be likened to lighthouses in the sense that they are serve as a guiding points or beacons to help define the decision. So
that is right. Very similar. You got that. So the whole question is, see, what will happen is, think of them as intersecting sets. There is knowledge in the retrieval, right? And there is knowledge that is in the parametric learning of the LLM, in the weights and biases of the LLM. There will be time that they will overlap. Both of them will have their answer. But there will be the time that one will have the answer, but not the other. And it could go either ways. So what you should do is, it's just a union of two sets, right?
Yeah,
you want the union of two sets.
No, actually, that was the follow-up, right?
Yeah.
If you look at it from an accuracy, see, the point is when it comes out of a RAG, I know this content was there.
Yes.
And that's why I love the concept of the RAG stuff, because when I pull it out of my RAG, I know for a fact it was there.
Yeah.
When there is an overlap or not an overlap, that's where the model starts cooking up story.
Making it from itself.
And that's where you kind of trap it saying, if you don't know, stop.
Yeah.
Like, don't pick up story, right?
Right.
And that's what I'm saying, the accuracy with a RAG, ARAG.
Yeah.
The form, I'm going to tell you in a computer science way or in an ML way, but I'm definite, because it pulled up in my RAG, that this is the answer.
No, you can never be sure. Yeah. See, remember the tail end of the RAG is always a LLM. LLMs inherently hallucinate. All that you do with fine-tuning and with RAG is, both are methods to mitigate its hallucination. But you can never be sure.
And the fact is, if I ask the same question and you ask the same question to LLM, both produces a different answer.
That is deliberate. The idea is that it will produce equivalent.
Because it is probabilistic, right? Predict the next word. So of course, the prediction will be different.
No, we start with a blank. There was open AI.
No, Prakash, there is a reason for that. See, if the answers are different, that's not a problem. If the semantic content of the answers are different, then it is a problem. So then it is
are different. totally different answers.
See, if the semantic content is different, but now they have become pretty good. They shouldn't be producing that. Especially with RAG, it shouldn't be producing that.
I mean, there is no RAG.
Oh, without RAG, yes. Without RAG, yes, it does happen. Without RAG, especially if the temperature is high, chances of hallucinations.
Customization. We just ask same questions
To ChatGPT.
Two people with no previous chat history.
Yeah.
And you ask the question, and I ask.
No, I think in ChatGPT, I don't remember, but somebody told me that confirm for me, guys. I think the default temperature is around 0.7 or something like that.
No, actually,
for variety.
Actually, there's other things as well. So if you look at some of their architectural things, they also are trying to optimize on cost and stuff. So they do have some caching strategies in that. So if I am asking the same question even days apart, it comes back with very similar answers. But if it's a different window, like what I'm saying is they're trying to optimize it with cache and stuff. They want to charge you for the tokens, but can I repeat the answer? And there's limited overlap between multiple people. So how that caching is also taking, it's not always coming from the LLM.
Srinath.
I've been hearing that, people have stopped fine tuning and instead they are going for RAG or similar techniques. Does this effort to what everyone else is thinking that fine tuning might not be the best option and instead?
See, Srinath, that is a common meme going around. It is there. Many people are saying that. Right? However, think of it as pure conceptually. The answers come from the parametric memory of our LLM, the weights and biases, and from the retrieved information. So common sense says that based on the question you ask, the information could be in either of the two places. Therefore, there is value in creating good content, a good search engine, a good semantic search engine, good embeddings, and in having a LLM as much trained on your specific data as possible. It is just dead obvious mathematical common sense. So, what is it?
Considering the cost of fine-tuning and all the
fine-tuning is not expensive. Fine-tuning is usually not expensive.
Generating this triplets using some kind of now we have to pay OpenAI. I'm not sure how much we have.
But it's
we have to pay. I mean, I paid. In fact, I can tell you how much we paid.
Yeah. All you missed too is damn expensive. That's millions. But fine-tuning, like what I'm saying is, if 5 of us sit together for a few hours and then you go run it on compute, what are you going to put it? Like $10,000, $5,000? What are you going to put it on?
How much was the cost?
Yeah, we can tell you the exact numbers, guys. To generate this fine-tuning data, just the data preparation, I ran it on this machine, and I believe it came to about $100 and some. And Praveen, I think once you run it on the fine-tuning, you raked up what, $7, $8 after that?
Yeah, that's pretty much, $5, $6 actually. For 4 million, they charge $1 for million token.
So for a product that will be, for something that will be in use in production, these are peanuts.
Can we say that, for the 80% accuracy, the RAG is enough to go the extra mile of
Absolutely. Yes. So Sheena's question is to get just 80% accuracy, is RAG enough? The answer to that is very much so. It's very good. Just see, a lot of people, you have to start somewhere. See, here's the thing. You have to get your first product out of the door, V1. So if you want to do V1, just go RAG. But at the end of it, what you're really worried about is not when you are right, but when you're horribly wrong. Because that is where your exposure is as a product. And that is where you start spending money and start investing in a lot of techniques to prevent those few cases where you can get horribly wrong. Right? I'll give you an example. I mean, well, I shouldn't at this moment, I guess we're on record, but there's some pretty damning examples of what these LLMs can do. I'm not quoting it because then I'll have to take names of specific companies that got into hot waters because of that. But let me just say that when those cases happen, it is a catastrophe. I mean, your company's parking lot will not have enough space for the number of lawyers who will sue you. So,
No, also, as if for all this fine tuning, you can add a lot of stuff actually, safety and security in the fine tuning.
Fine-tuning, yes.
My question is, then why not fine tune this Mistral or newer models versus going through OpenAI and fine tuning?
No. OpenAI was not used to fine-tune. They have fine-tuned Llama 7.
His point is Azure, like all the enterprises are doing OpenAI on
Fine-tuning, yes.
Yeah.
No, that is a very good question. So Prakash is asking, why are we not fine-tuning our open source models instead of that? Partly is brainwashing. Remember the marketing budgets of those guys, Azure's and the cloud providers. They're convincing everyone that that's the way to go. But the fact of life is open source is doing very well.
But if you are trying to do something with fine tuning, I think the onus is on you to try it with OpenAI, with Mistral, with Llama, and see what produces better results, right? These are all just variants. Should I fine tune? Should I use RAG? Should I use open source models? Should I not? What kind of chunking do I do? What can I don't? This is all variable.
It's all very experimentally, very experimental.
And there was one interesting problem called sentiment analysis, right?
Yeah.
In the sentiment analysis, the all this chunk of text may represent, different contexts. So
It does. See, sentiment analysis by now is more or less, you consider it's, see, the problem with sentiment analysis is regular text, it gets the sentiment right, very accurate. A problem comes when you do not just positive, negative sentiment, but say classify it into irony, sarcasm, laughter, happiness. You give a range of 10 or 12 different emotions, anger. Then you have to, because it's a case of zero-shot learning. Remember, we covered that in the neural architectures course. It's a zero-shot learning problem. But then accuracy begins to take a hit. Then you need to fine-tune, and it really helps. Now, the problem that is there with that is, most times sentiment analysis works well. It is still doing poorly with sarcasm. Even LLMs do poorly with sarcasm, right? So that's a case that is a glaring problem with sentiment analysis. But other than that, it works pretty good. I'll give you an example. See, somebody said in logic, they say, right, that the negation of a negation is positive. I didn't not do it. Means what? I did it, right? But the positive of a positive is not a negative, right? And so when a professor was saying this in a class, at the back of the class in US, there was a student who was sitting and he just says, yeah, aha, in the most sarcastic way. Now, both of those are positive statements and it pretty much refutes whatever the prof was saying. So you have to know that language is a language, the intonation and other things are not captured. And sometimes a lot is said in the non-verbal aspect. So there's that.
Yeah, Asif, pretty much done. So yeah, that's what Asif, we need to compare the RAG result and the fine-tuned result once we have both running. Then we know exactly how much different they are.
Yeah. Logically, though, I would suggest, guys, that when you go into production, use both. Fine-tuning is work, but it is not expensive. You should do that. Yeah? Likewise, RAG. See, remember, when you say just plain RAG, by plain RAG, you mean just search plus a generic LLM. Generic LLM can be improved easily. You do improve it, but even if you use search, remember, fine-tune your search. How do you fine-tune your search? By fine-tuning what?
The cross-encoding.
Exactly, the embedding and the cross-encoding.
How you ingest it. So, for example, when we looked at this, we came up with chunks and we said the similarity threshold has to be very high, right?
Right, yeah.
Literally what we realized is all the chunks came out as a single sentence.
Right.
Because they're like literally like, even if you look at the English as a language and the structure of a paragraph, right? You start off by, oh, it's a beautiful day and the birds are chirping or something like that, right? The two sentences, the correlation is going to be low.
Yes, exactly.
So if you put the threshold very high, you will never get a paragraph out.
Absolutely.
You will get single sentences, right?
Absolutely. Satyam makes a very good point that even fine-tuning hyperparameters, like for example, what is the similarity threshold at which you break a chunk boundary? right? If you make it too high, every sentence will become a chunk. If you make it too low, then obviously you have other problems, right? It becomes too long. And it depends on linguistics. I was trying this out. When you look at scientific literature, because they are well argued, the sentence similarities are pretty high between adjacent sentences. But try reading New York Times. If you look at the journalistic style, they take a lot of pains in good writing. Like the language is important. But if you look at the similarity between sentences, very low similarity, because there they put a premium on not being repetitive, in saying things in the fewest words possible. And so sentence to sentence, unless you use a very low similarity, you accept it, you will find that every sentence of New York Times, right, will become its own chunk.
So the observation I wanted to share was a very high threshold gave me single sentences versus paragraphs.
Yeah.
But the RAG output with a general LLM was substantially better when the chunks were small. Substantially better.
Substantially better.
Because what it would do is, when I said, what is being searched, it would literally find 6 very good sentences for it.
Yeah.
It would give it to the generative thing. We've not got into fine-tuning, but that would be my next experiment around.
Yeah.
Single sentences, very high value, very high similarity to the question.
Yeah.
Got regular LLMs to give very good answers. If I gave it paragraphs, it was bad answers.
Nice. Yes, Satyam is sharing. Those of you remote, if you didn't hear it, he pointed out that he found that if you use very small chunks and feed it into RAGs, the RAG result was actually better, because it was finding very specific best sentences as chunks, surfacing them and feeding them into the LLM. And so the LLM response was good. That's very nice. See, guys, this field is as much art, as much experimentation as it is science. We are in a very fluid world. In fact, things start really from the foundations. Nobody understands what is it that the LLM is thinking if you ascribe them with the quality of thinking. What is it that they understand? We don't know. For the longest time, like even I used to say that, oh, LLMs, transformers don't memorize. And now I take it back. It turns out that you can literally extract training data out of a transformer, which means that it has done a lossless internal representation, memorization of the data in some form that you can reconstruct it back. It is not memorizing and still memorizing, right, in some sense. So we are in uncharted territory. We are discovering the qualities of these are weird beasts. We are discovering their properties as we go along.
So if somebody should come up with language for prompting. This is how you write.
It will evolve. It should evolve. Yes, there should be a specific. I'm sure people are researching it and coming up with it. And I would say that Instructor is a very big library, is a very big step forward in getting the responses and so forth. So
this is Stanford group doing that with DSP.
I think, yeah. Okay, Patrick, you want to show the demo? Patrick? Praveen, demo. I think they have dropped off entirely.
No, Asif, yeah, sorry, I was on mute. Okay. So Patrick will do the voice demos.
Okay, nice.
So I'm pretty much done, Asif here. You want anything to?
No, this is it. And Hamad, are you ready after that? Where is Hamad? Do we have a lunch break? It's 2:21. I was actually thinking that we'll finish off, but if you want a lunch break, we can take a lunch break.
Finish off.
Let's finish off.
Finish off. Let's finish off, guys. So, all right, let's have a demo and then move forward. Oh, Patrick isn't here, is it? Praveen, Patrick dropped out?
No, on the online I can see.
No, but we can't hear him.
Yeah, we can't hear.
Oh, he's reconnect.
By the way, I hope you guys are finding this project discussion sessions useful.
Yes, Asif. So, Asif, I had a question. So, Asif, we have to have a metric, right? We discuss a lot of techniques that RAG improves this way, ARAG improves in this way, cross encoder does. Having an LLM to re-rank the vector also help. And I mean, when everybody comes up with their own systems and their own products, you need to have a metric, right? In terms of how much, like the quality of the answer that the AI system can produce. That is my question. Actually, my question is 2 or 3 parts. The other one is, will it involve creating artificial data sets to improve your quality of the results? And the other one is, will it involve re-architecting the LLM itself to get to improve this AI system?
Jay, the answer to all of your questions is yes. First, we do need benchmarks. So people have created benchmarks. They are standard data sets on which, if you look, for example, the Gemini release, they have compared their LLM against, or their system against all the standard benchmarks, and they have shown how do they compare against other LLMs. Second part is that we need to create special synthetic data sets to do some of this benchmarking. People are realizing that the data sets that they have may not be perfect. They're trying to create even better data sets for benchmarking. Some of these data sets are synthetic. The last part of the question is, do we need to re-architect the LLMs to make them better? Oh, that is an unending exercise. Every single day, literally, yet another new idea comes on how to improve the internal architecture of these things.
Right. Okay.
It's an ongoing.
About the metric, Asif, so that is, is there, is there a metric that you can think of?
Different tasks, like for example, for their perplexity measures, there's precision, there's recall, and so on and so forth. How about this? Because there are different metrics for different tasks that you put an LLM for. I can give a short talk going through all these metrics and the tasks and the benchmarks, because this is one of the things I didn't quite cover properly. How about I do it in a proper session?
Okay.
It will take a couple of hours.
Oh, I see. Okay. Thanks, Asif, for your freedom.
Yeah, I'll be happy to do that. In an hour, hour and a half, I'll be happy to do it.
Thanks.
I'm having a problem with the microphone on my computer, but I'll try to see if I can demonstrate.
Sure.
Okay. Okay, so let me share my screen. So after we did, the idea was after we had created the fine tune, the idea was to have a way to connect the audio input and an audio output, and we were tasked. So I was tasked after we did the prompt engineering, the data set generation, and then Praveen started working on the fine tuning steps. I had also explored 11 labs. So I created the Asif voice clone. It uses 25 audio samples from your lecture. So I had pre-made about 25 audio samples, and some of the other members also helped. We created this, and then the goal was to create a system, and because my microphone is not working in my computer now, Murphy's Law, it's probably, it's not, it's supposed to take in an audio and transcribe. Oh, it is. Okay, there it is. Okay, so let me test this now.
Make sure you're sharing your voice on Zoom.
Okay, sure, Asif. Let me try that. Share sound. Okay. So this is it. I hope it works.
Let's try.
So right now, this one doesn't focus on, this one isn't using the fine-tuned model that we had built because the fine-tuning did not arrive just in time. So I had used OpenAI as just my generic backend. So this will just ask OpenAI a generic question and then Asif will read out the answer. So originally it was speaking, but because I didn't reply within 3 seconds, it defaulted to a text output. So now I can just ask a generic question. So maybe we can ask, describe L1 norm in machine learning.
The L1 norm, also known as the Manhattan distance or lasso regularization in machine learning, is the sum of the absolute differences between the true values and the predicted values. It is often used as a regularization technique that encourages sparsity in the model coefficients, potentially leading to simpler, more interpretable models that avoid overfitting.
So we'll ask Sona, does it sound like me? Sort of, yes.
So under the hood, this is also using the same technologies. In fact, this is inspired by Jay Shankar's presentation last time, where we did the same process, but this was optimized for latency. As you could see that what essentially is doing is it's because OpenAI has a text streaming output, and 11 Labs also can take in a text streaming input. What I did was as the text streaming output of OpenAI is being generated, I created a queue that batches it per sentence, and then it sends the whole sentence to 11 Labs to get streamed in real time. So you could see there's just maybe like a second or a second and a half delay between the text that's being printed and the actual audio output. So this was one thing that we had done, and it works. It works. You can listen. So if we wanted to ask, maybe if we ask it again, I'll ask another question now. What is contrastive learning loss in machine learning? Answer within 2 sentences.
Contrastive learning loss is a type of loss function used primarily in unsupervised learning that encourages a model to learn similar representations for similar samples and dissimilar representations for dissimilar samples. It often involves pairs or groups of data points, reinforcing the model to push apart the representations of negative pairs, dissimilar, while pulling together those of positive pairs, similar.
Nice. This was a little bit more like me, isn't it?
Yeah.
Patrick.
Yes, Jay.
Can you go to the 11 Labs, the API thing, that you showed? I mean, I'm just seeing whether we can. Okay, you have the Indian tagged. That is good. I don't know, what makes it sound a little off Indian, but the performance is way superior. This is nice, Patrick.
Sounds a little more like a stuffy Englishman than the Asif we know.
That's what I was about to say. I think he sounds a little more English instead of. That's why I wanted to bring it closer to the Indian by adding the tag. But yeah, it's a little closer to the English one, and this is because I'm using the 11 Labs Turbo version 2 instead of the multilingual version 1. The multilingual version 1 will get you really good clarity, but at the cost of a lot of time delay. So this one was just another way to optimize, make it a little bit faster. But I did have yeah.
Patrick, you need to add a tag there. Instead of saying Indian, say very thick immigrant Indian accent. Off the boat accent.
Yeah,
Not really.
And then the final piece that we were supposed to connect, we lacked a little more time and some expertise in UI. But the whole goal was after the audio had been created, I was gonna send it to another AI model, and I'll do this in real time. So it's training it in real time. And as you can see, well, this is using a 3080, a mobile 3080, but it was fast enough. And then, so let me just play that real quick. Oh, is it the response? Sorry about that. Was the results? Supposed to be. Oh.
Last couple of years has been that your go-to approach should use transformers for most of these things. They tend to have better performance. Right? And throw in a CNN, but don't forget to bring in attention head somewhere.
So yeah, we were supposed to introduce a lip syncing model, as you can see from this picture. The goal was to get the audio output stream, save it into an audio, and then send it into the lip sync model so that you can see us talk in real time.
That's great.
That's that.
Yeah.
And if you look at the results, guys, you would.
So this is our proof of concept. Unfortunately we didn't get to stick it all in time.
By the way, this picture is from 2017. Yeah, when I used to be much younger.
Yeah. Yeah, only thing, hair is not moving. That's what I was telling. If you need to have.
I was gonna say that there's just latency.
I was on a boat on the Ganga River in Paris, enjoying a nice winter morning, and somebody took a picture of me.
Great. Yes. So that was it. That concludes everything we had for our presentation. And yeah, just wanted to thank everybody and our teammates for all the participation and hard work, and for you, Asif, and the rest of the team for teaching us and keeping us improving. Really.
Right, lot of hard work. You guys have done a lot of innovative stuff. Is really good, and especially the fine tuning part is amazing. It's very good.
Thanks.
Thank you, Praveen and Patrick. We kind of learned quite a lot from you guys. Shared a lot. Thank you.
Thank you.
Yeah, no, this really reinforces to me the fact that we are a learning community. See, in learning, in education, they say that you learn from lectures. That's one learning. You learn by doing, by doing homeworks and exercises. You learn a lot from projects because projects create a social environment of learning. So social learning, where you learn from peers, is really the framework in which learning sinks deep and takes roots. And I really am appreciative that you all encouraged each other. Every team came forward and encouraged other teams in helping us all collectively have a great learning experience. That speaks to the fact that it's a community. There's an old African saying, right, that it takes a village to raise a child. So from that perspective, it takes a community. Really, it takes a learning community to learn something. See?
Great job, Praveen.
Yeah.
And the rest of the team. So,
Thank you.
A lot of us didn't do.
Yes.
Fine tuning was like really high on your thing, and that was really good. We kind of learned a lot from that.
Yeah. Hamad, you are next after 10 minutes break. Are you ready?
Yeah. Yes.
So share your screen and be ready. We'll just take a. No, I think people have already taken a break. I can see them munching food. So, so let's get started.
That's not break, that's work.
Okay. All right, Hamad, get started.
Okay, let me share my screen.
I must say, while Hamad is getting ready, he's unique. It's a one-man team. He started out, he is just, by the way, what is even more remarkable is he has just entered this field. He started learning machine learning in the summer of 2023. And since then, he has come, you can see how far he has come. He has picked up a lot. He and his brother Anas, who I don't know if he's still around, both of them, they are very, very, like, they have native talent. Like, they just love coding. They can spend endless hours just sitting and quietly coding. And the effects show. It's really nice to see this. Hamad, you ready?
Can you guys see the screen?
Yes.
Okay. So I'm also in
Are
like
we
a
going to
P-
record this, Asif?
Yes, we should.
So I'm also in a POC kind of mode. After Patrick had showed me the streaming coming out of what's it called, 11 Labs. So my entire project used to run of off of GPT-4 and 11 Labs. It now runs from Gemini streaming, and then the chunks streamed from Gemini go straight to 11 Labs. So if I send a query here, uh, so the yeah.
Does the language look like mine?
Yes.
Nice.
So I ran into a little problem with the way that 11 Labs is handling the streaming. I think Patrick set a delay. I asked him about it yesterday on his. That's probably the fix here, but it stutters a little bit if the next chunk in the text generation hasn't loaded yet. The audio. That's why I got stuck after I can. But other than that, so this one is without RAG. The working version with RAG is a bit of a mess, but we can run it.
Because it says things very similar to what you said.
It does. I think
So if it didn't have RAG, it didn't have fine tuning, how did it produce that?
you haven't used fine tuning, right? Or have you?
So the only thing that I had added on that first model was if you go here to LangChain, there's just a small prompt instruction right here. So it says, I am an AI assistant imitating Dr. Asif Kumar's speaking style and mannerisms. And then it goes on with just a bit more
Oh goodness, I need to read this prompt. Can you post it to this sentence?
yeah, I can send it. But
I will know how you think of me.
So the RAG script, 11 Labs has been really iffy working with it. But if you have like if there's a question you want to ask it.
Just wait a minute. Satyam had this question. How is it able to imitate my mannerism and style so well? If you are not using RAG, what it means is that OpenAI has scraped my content and now knows me, knows my style. That's the only explanation you can give, isn't it?
Or the fact that he's been interacting with OpenAI
with this content, yeah.
But there could be also the vector database is giving him the.
No, he's not using vector
He's not using
database.
that. Oh, no,
No RAG, no fine tuning at all. And yet the OpenAI now is returning with my mannerisms. That's scary.
It's just the text instruction. Like the way it works, the link change pipeline, when the chat first starts, there's already been two sample messages that have went through. The first message is a sample message from the user that's just hi, but this prompt instruction that the AI uses, it classifies it as a message that the AI has already sent. So
Okay,
like
right. Enough it. First of all, you're not using OpenAI, you're using Gemini.
Yeah.
But does it mean that Gemini somehow knows my style, or
no, so the results have been pretty similar. I can send this text script. When I had run it on GPT-4, the like the tone of the answer was very similar still.
No, but the question that is being asked, Hamad, you're not listening to the question.
Oh, okay.
The question is, without RAG and without fine tuning, how is it that these LLMs, whether it is Gemini or OpenAI, how are they able to imitate my mannerisms in the answer?
No, that is due to prompt, Asif. And also, YouTube is owned by Gemini, right? Gemini and YouTube, they must be known.
No, that's the point I'm making, Praveen. It means that Gemini and OpenAI, all of this, it means that the public videos that I have put there, they have already become inputs to these models at some point.
No, I think most of it is just the prompt because I've added some stuff like this where it's like
this is it. This is it. You hard coded it. You hard coded. You hard coded.
What we also did initially, remember,
Okay.
we have one liner there. So hi, if you come from there. So I think it is hard coded.
So this is the explanation. Yeah, I was worried that.
Different questions, then we'll know.
But then so the version with RAG, if you have a query to send it, do you have something that you want to ask or?
Yeah, it would be nice to hear the voice, but let's say, why are neural networks considered universal approximators?
Were you guys not able to hear the voice the first time?
No, because you didn't share the voice. You have to share the
Oh,
voice.
so sorry. Okay, let me run the first one then, because that one has the voice working with streaming.
Okay.
One sec.
I found the Medium article you shared, Asif, how to measure the success of RAG system.
Oh, nice.
Thank you.
Oh, oh goodness, this sounds so cheesy. Where's the sound though? No, you have to share the sound, Ahmad, in Zoom. In the Zoom
No,
settings.
okay, one sec.
In the meanwhile, guys, just a show of hands. How many of you, is there anyone who is not registering for part 2? Are you all registering for part 2? You are not. Okay, one dropout. You're registering for part 1?
Part 1.
Yes. Anil, are you registering for part 2?
Oh, when?
Starts in towards the end of January.
I'll see.
Okay, nice. So 2 dropouts. The rest of you are joining. See, if you're not joining, just give me a show of hands, because I have to arrange for the logistics, food, and if the number of people joining would be less, then I will acquire one of the rooms for storage, computer storage, and so forth.
So are you doing the parallel one, or you just doing only spread ones?
No, parallel. The LLM first one is this thing will repeat
that, right? So Saturday, Sunday, Saturday.
2024, teaching will be pretty intense. There'll be 2, the LLM 1 will run and LLM 2 will run in parallel.
Okay.
Introduction to machine learning in a comprehensive intro. Okay. That will also run in parallel. So 3 courses will run in parallel.
So I thought Saturday, Sunday, or? I thought you said you're going to run in weekdays or something.
Weekdays, some of these. No, the date I have to decide though.
Oh, okay.
Yeah.
So weekdays you'll do the intro, and weekend you will do one. Saturday you'll do the LLM 1, and Sunday you'll do LLM 2. Is that
either that or LLM 2 I may do on the weekdays. See, people who are abroad, right? They're saying that it's not fair to them because they have to literally screw up their entire sleep cycle and to attend this. And there are people who are wanting to attend actually from countries like Georgia, Azerbaijan, and Malaysia, Indonesia, etc. For those people, it becomes very, very hard to do a Saturday one, and they are requesting if we can do an evening one. No, so
for LLM 1, you're saying.
For the LLM 2. So I'll see. Or alternatively, so far the registrations for LLM 1 have not been so many. So the few ones who have registered, I mean, actually the numbers are increasing daily, but if I can go back to them and convince them to move over to weekends, I mean to weekdays, that could be an alternative. When would you prefer?
Me? Oh, weekends.
You also prefer weekends.
But yeah.
Then it's possible we'll do Saturday, Sundays.
Weekdays, what time you think? Evening is good.
7 to 10.
That should be fine.
7 to 10. Anybody has very strong objections to evenings, 7 to 10? Prakash, other than Prakash.
Somewhat.
Yeah, because they have to run. Yeah, most people have to be works for the best. Okay, so then it may not be Saturday, it may become Sunday, but that's, I hope it's okay. Yeah. Okay, Hamad, are you ready?
Yeah. Okay. So
oh goodness, please don't come back with a cheesy response. Let's see. Yeah, your audio isn't working.
Okay.
It's really strange. If I ran it without the Zoom audio playing, and the audio went through, but okay, one sec.
Hello there, my inquisitive pupil. How may I assist you today?
You're able to hear this.
Yes.
Yes. Yes, that's
a perplexing problem from the realm of AI, or perhaps a burning question about the latest advancements in machine learning. Ask, and I shall endeavor to provide you with the knowledge you seek, isn't it?
Oh God, I hope I don't use such.
This is sort of like a mix of a little bit of a chipper British guy and a helpful genie. That's not quite Asif, but close in some ways.
Some 20 years younger, right? full of zest.
Yep.
The pitch is good, no?
Yeah, the voice,
There are
yes,
three
some
different components.
pitch is good. Yes, that's true. It's a good imitation. At the same time, yes, like Kate said, it sounds like the genie that came out of the magic lamp. That's right. Very nice, Hamad. Great job. This is very nice.
But yeah, I think that's it though. For now, the streaming did take a while to figure out. Like sending it from Google to 11 Labs, it still is really like it's still very jittery, where one sentence will load within a millisecond, and then the next sentence will be like 2-3 seconds later, and the audio will play like another 2-3 seconds later. So it's just a mess right now, but that's what I have.
No, that's all right. This is still great work, Hamad, for a person who just started learning or entered this field a few months ago. This is exceptionally good progress. Great job. Great job. Beautiful UI. All right, folks. So with that, I will end the